In this lesson, we will be solving quadratic equations by finding square roots. The first thing that we need to do when we're solving a quadratic is take a look at the original equation. If the original equation contains only an x squared and not an x term, then we can solve in this way. We will get the x squared by itself. So the first thing we'll do is we will add 30 to both sides. And we will have 5x squared equals 100. And then we'll divide both sides by 5. So we have x squared then is equal to 20. And so now to solve, we will do the opposite operation to get rid of the square, which is to take the square root. A square and a square root cancel each other, so we have x equals. Now when we do this process, we do know that we aren't sure if we want the square root to be the positive value or the negative value. So since it is a variable, we will need to have both the positive and the negative square root of 20. Our last step will be to simplify that root. We'll make our factor tree. And so we actually have x then is equal to plus or minus the square root of 2 squared times 5. And we know that the square root of 2 squared is 2, so our final answer will be x equals plus or minus 2 square roots of 5. When we take a look at our next example, we see we don't have a quadratic that has the middle b term, or the x, we just have the x squared. So we want to get the x squared by itself, so we're going to add 6 to both sides. So we have 4x squared is equal to 48. And then we're going to divide both sides by 4. So we have x squared is equal to 12. To solve, we do the opposite operation, which is to take the square root of both sides. So x is equal to plus or minus the square root of 12. When we make our factor tree to simplify, 4 times 3 or 2 times 2 is 4. So x equals plus or minus the square root of 2 squared times 3, or x equals plus or minus 2 square roots of 3. It is my hope that you will soon get to the point, if you see something like the square root of 12 or the square root of 20, that you remember there is a perfect square, 4 times 3, and that you know that the square root of 4 is 2. So should get to the point where we don't need to write out this part right here, where you can go from the square root of 12 to being 2 square roots of 3. Or when we get to the point where we know that the square root of 20 simplified is 2 square roots of 5. In our next example, you'll notice we also have just an x squared and we don't have an x term. So we want to get the x squared by itself. We're going to subtract 3 from both sides. So we have negative 5x squared is equal to negative 12. And we're going to divide both sides by negative 5. So we have x squared is equal to 12 over 5. To simplify, we need to take the square root of both sides. So we have x is equal to plus or minus the square root of 12 over the square root of 5, using our quotient property and knowing we can separate those. From the previous slide, we should remember that the square root of 12 is 4 times 3. The square root of 4 is 2, and we can't simplify the square root of 3. And then we still have our square root of 5 remaining in our denominator. But we can't leave a radical in the denominator, so we're going to multiply both the numerator and the denominator by the square root of 5, so we can rationalize the denominator. So x equals plus or minus 2 square roots of 15 over the square root of 25, which is 5. And please remember that the square root of 15 and 5 are not the same. This is a radical and this is not, so we can't simplify those any further. In our next example, we have an x squared only, not an x term. So the first thing that we're going to do is we're going to subtract 4 from both sides. So we have x squared over 12 is equal to 2. And we're going to multiply both sides by 12 so that we can get the x squared by itself. So we have x squared is equal to 24. To simplify, we're going to take the square root of both sides. So we have x then is equal to plus or minus the square root of 24. The square root of 24 can be broken down into a factor tree of 4 times 6, 2 times 2, and 2 times 3. So when we rewrite the factor pairs underneath the radical, we're going to have 2 squared and 2 and 3. So that's going to leave us with x equals plus or minus 2, and then 2 times 3 would be the square root of 6. Now in this example, you'll notice that we have this quantity being squared, so that's what we want to get by itself. In order to do that, we have 1/2 times that, so if I multiply both sides by the reciprocal, which is 2 or 2 over 1, any number times its reciprocal is 1, so that leaves me with the quantity squared by itself, and that equals 16. So I can do the opposite operation to get rid of the square. I'm going to take the square root of both sides. Then remembering that a square and a square root cancel each other, I'm left with only x minus 2. And then the square root of 16 would either be a positive 4 or a negative 4. So don't forget the plus or minus. To finish simplifying, we're going to add 2 to both sides. And that 2 needs to be written out front, in front of the plus or minus. So I'll have 2 plus or minus 4. To finish simplifying, we just have 2 math problems to do. We have 2 plus 4, which is 6, and we have 2 minus 4, which is negative 2. In our next example, similar to the first, we have this quantity being squared, and we want to get that alone, so we're going to get rid of the 1/5. You could change it to a decimal, 0.2, or we can simply multiply by the reciprocal, which is 5 over 1. So now we have any number times its reciprocal being 1, so we have 1 times the quantity x minus 4 squared is equal to 30. So we're going to take the square root of both sides, which is the opposite operation, and it allows us to get rid of the square. So now what I have remaining is x minus 4 equals, don't forget, plus or minus the square root of 30. There's always 2 roots, the positive or the negative. So the square root of 30 can be simplified. Let's check. 6 times 5 and 2 times 3 for the 6. So we have 2 and 3 and 5. No factor pairs. And those of you that are using perfect squares, there is not a perfect square in 30. So to finish, we're going to add 4 to both sides. So x then is equal to, we write the 4 first, and then we put the plus or minus the square root of 30. And that would be our solution for that quadratic. In our next example, we have our 3 as a leading coefficient, and we want to get the x minus 2 quantity squared by itself, so we're going to divide both sides by 3. So we have the quantity x minus 2 squared is equal to 7, and so we are going to take the square root of both sides. So we have x minus 2 is equal to plus or minus the square root of 7. The square root of 7 can't be simplified, so we'll finish by adding 2 to both sides. So x then is equal to 2 plus or minus the square root of 7. In this example, we're going to divide both sides by 5. So if we have x minus 7, the quantity squared, is equal to 27. To simplify, we're going to take the square root of both sides. We have x minus 7 is equal to plus or minus the square root of 27. If I were to make a factor tree for 27, I'd have 9 times 3 and 3 times 3. So when I'm simplifying, x minus 7 is equal to plus or minus. Remember, I'd have 3 squared under the radical and then a 3 by itself. So if I have the 3 squared under the radical, I can take the square root of 3 squared, which is 3, and that leaves me with only a 3 under the radical. I'm going to add 7 to both sides to finish solving, so I'll have x equals 7 plus or minus 3 square roots of 3. As we finish, I'd like to show 2 different situations that you might want to remember. So if I come down to a situation where it says x squared equals negative 9, and I were to take the square root of both sides, please remember that the square root of a negative number is not defined for the real number system. We'll get to that shortly. But in this case, if you were to be given a problem now and asked to solve it in the real number system, the answer would be no solution. Same thing if you had a problem like x minus 3, the quantity squared, equals negative 10, and we were to take the square root of both sides to solve. Since we're working right now in the real number system, we would have no solution if we are in the real number system. So, when we're solving quadratics, be sure to get the x squared or the quantity x squared by itself, then take the square root of both sides, and then finish simplifying. Please complete the reflection.